Hello, welcome back to my online tutorials. Recently, I started a new series on Docker. This is my third video on Docker series, which is on Kafka. We are going to explore a lot of interesting topics on Kafka. Let's begin the video. This video series is for the folks who are looking for real-time scenarios, hands-on experience on Docker implementation. Like all the demos will be explained step by step, and all the scenarios will be taken from the real-time projects. So, what is Kafka? Apache Kafka is a distributed event streaming platform designed to handle real-time data at massive scale. It lets applications publish, store, process, and subscribe to continuous streams of events with high throughput, low latency, and strong durability. I'll try to explain what is Kafka in simple terms. If you already aware of some message-based tools like MSMQ, RabbitMQ, Azure Service Bus, Azure Event Grids, and Azure Event Hubs, so Kafka will fall under same category, but with great advanced features like its distributed event streaming platform. Like if your application is dealing with huge stream of data and huge events, then Kafka is a best tool. And it's it has a lot of advanced features like high throughput, low latency, and strong durability. So we will see the real-time implementation of Kafka, but you can think Kafka as a message-based tool which will allow you to process huge streams of data. Some more details about Kafka. So Kafka acts as a central nervous system for data, capturing events from many sources like databases, services, sensors, and applications, and making available them to many consumers in real time. So, like as I mentioned, it acts like a event hub, so which will be used to capture multiple events from different sources, and then it acts like a pub-sub model, so where the producers will write the events and consumers will read the events. And durable event storage, so events are stored in an append only replicated log for as long as needed. So one of the beauty of Kafka, like you can use the log system efficiently and effectively, and there are a lot of uh, like logical and mathematical things you can do with the logs. And stream processing, applications can process events as they arrive or reply them later. So the events will be processed like in the order they arrive. So these are the high level features of the Kafka, but we will see them in detail. The implementation, like how the PubSub works and what is the durability and what is the stream processing. And even you can write the filter. There is a KSQL called Kafka SQL, which will allow you to pick the if 100 similar messages submitted to the Kafka, you can write a logic in KSQL which will pick the topmost uh, uh, latest message. Suppose if I'm sending my information and which is same uh, as 100 messages, the Kafka is not going to process all the 100 messages. By using KSQL, you can filter them and it will process only the topmost, the recent most record. So there are a lot of wonders we can do with Kafka, and we will explore them going forward. So why Kafka is powerful? Kafka is built for high throughput. So if you are writing an application for simple messaging, and Kafka may not be suitable. If you want to explore or if you want to utilize maximum features of Kafka, use it for high throughput. The Kafka is designed for high throughput, like millions of records you can process within no time. So Kafka is built for high throughput, fault tolerance, and horizontal scalability. So you can scale the Kafka horizontally, often handling millions of messages per second. As I mentioned, you can use Kafka, you can best use Kafka for processing millions of messages per second. It was originally created at LinkedIn and later open sourced under the Apache Software Foundation. So key architectural strength included for Kafka: distributed broker that scale across servers. You can distribute the events across the servers. Topics and partitions that parallelize processing. You can create multiple topics and even multiple partitions. A single topic can have multiple partitions. Replayability, allowing consumers to reread data at any time. So the like consumers who wants to see the already processed data, they can do this replayability. This is called replayability. And decoupling of systems, reducing point to point integration. So if you are using Kafka, the microservice pattern, you can decouple all your services and you can stream the data in the best process. And as I mentioned, we will see feature by feature in detail by the example um, and in the next slides or in the next videos. Yeah, so now how Kafka fits into modern systems. So the Kafka fits into modern systems because Kafka is widely used for real-time analytics and dashboards. If you are dealing with real-time data and if you want to analyze and you want to process that, Kafka is the best solution. Event-driven microservices. So each message we call it as an event. So like millions of events can be reached to Kafka, and Kafka will allow you to process them uh, without any hardness. And log aggression, Kafka has extended logging mechanism where you can log information as much as possible. And fraud detection, like there are a lot of features which will allow you to detect the fraud messages or the similar kind of messages. IoT data integration, internet things of data you can integrate with the Kafka. Data pipelines between operational and analytical systems. So aggregation pipelines, the best way to process Kafka data is by using the aggregation pipelines and other data pipelines. So we will see how to define the pipelines and process the data. So these are some, uh, because of these strengths, Kafka is widely used. So like, I'm a fan of Microsoft. So, but still, I love the Kafka because Kafka has many features. So definitely, when I looked at Kafka, I tried to see what is the competitor. So Azure Events Hub is the best competitor for Kafka, or you can take them side by side. So we in this slide we are going through the advantages or the features, the comparison between Kafka and Azure Events Hub. So deployment, you can deploy the Kafka self-managed anywhere you can do that. And event hubs, it's fully managed, but they are only on Azure premises. You can deploy Kafka in your local, in Linux, in any server, but the Azure Events Hub you can deploy only in the Azure only, and it's fully managed. So protocol, native Kafka, and Azure Events Hubs Kafka compatible. Scaling manual, you can add the brokers, you can scale them manually. And Azure Event Hub, they are automatic like TU and CUs. Um, and ops overhead for the Kafka is very high. Uh, for Azure Events Hub, it is low because it's fully managed. Azure Event Hub is fully managed ecosystem, huge open source ecosystem. So as Kafka, as I mentioned, Kafka was um, first used by LinkedIn, but then it moved to the open source by Apache. And Azure Event Hub, it's deep Azure integration. So if you are using a Event Hub means you have to use Azure, but Kafka is a open source. Networking, multi-broker endpoints. You can use multi-broker endpoints to manage the network for Kafka, but here single virtual IP. So if you are creating a Event Hub, then you will have a single virtual IP. So when the Kafka is best used for and when the event hubs best used for, this is the answer. If you are control and customizing your events, then Kafka is the best. If you have more control and you need more customization to your events, then use Kafka. If you are if you need simplicity and cloud native, so if you are using event hubs, then it's completely cloud. You cannot use Azure event hubs in your local or in any other system. It's completely cloud. But if you are looking for more customization, go for Kafka. So then how to create Kafka in Docker? That is our topic. So there are two steps: define Docker compose file and run this command. Compose Docker compose up -d. So these two commands, these two steps you can follow. So let's review. There are different types of Kafka. There are two types of Kafka, and we are going through in the next slides. So here I defined two Docker Compose files. So this Docker Compose is Kafka, Docker Compose Kafka, and this uses Zookeeper. So the Zookeeper is the traditional and it's a legacy way to create your Kafka. But this Docker Compose, it's going to use the latest Kafka like version you can think, or the version or the variation of the Kafka. So these two we are going to see in the next slides. Yeah, so these are the details of the Zookeeper Docker Compose file. So here in the services it's mentioned Zookeeper. Uh, this is the image information, Confluent tick CP Zookeeper, and this is the version and container name. It's going to create as a Zookeeper, and these are the ports, and these are the environment variables, and then this is the image for the Kafka. So here this is the image for Zookeeper, and then this is the image for Kafka, and this container name, and this container is dependent on the Zookeeper container, and these are the environment variables like Kafka connect, and also like what is the local host name, where the Kafka will listen, all these. So this is the legacy and the traditional way of creating Zookeeper Kafka. And in the next slides, we are exploring the latest way how to create the Kafka. So this is Docker Compose file to create Kafka with the latest version, and that is called as KRaft, KRaft, Kafka Raft. So this has a little slight different ways. So the services, it's going to use Kafka, and the image is Confluent CP Kafka. Here it's CP Zookeeper, but here it's CP Kafka 7.5.0. So container name Kafka. So in the if you are using Zookeeper, you have to create image for Zookeeper as well as the Kafka. But here just creating Kafka container for Kafka is enough, image and container. And these are the ports, and these are the broker details, environment, the processes. It uses a broker and controlled. So most of them are like uh, the same you have to use if you are going to use the KRaft. And these are the listeners. And this is the security protocol, plain text internal, plain text controller, plain text. So, and this is the cluster ID. You have to define the cluster ID. So if you are using KRaft, it's more broker centric and cluster centric. The Zookeeper is a traditional way. And this is for Kafka UI. So this part, if you are creating only Kafka, then the highlighted part is sufficient. But I want to see the Kafka topics in the browser. I want to create them and I want to add the messages, read the messages in the browser. For that, you have to define this Kafka UI. So where Kafka UI, the image will be uh, Provectus US Labs Kafka UI latest. This is the image name, and container name you can give Kafka UI, whatever, and ports. So this is the port where you can log in the browser and see the Kafka instance, the local Kafka instance. And if you are using it in server, it will have a server instance. And the cluster name is the local and the bootstrap servers. And this container is dependent on the Kafka container, which we defined on top. So this Docker compose file is going to create Kafka KRaft, the latest version of Kafka in your Docker desktop. And this section is defining the UI so that you can browse Kafka instance in your local, and you can create the topics, you can add the messages, read the messages, uh, update the messages, and etc. So let's run these queries. Let's execute this command and see. I'm not going to create Zookeeper. I'm only going to create KRaft, which is the latest version. So this is the Docker. I just cleaned up my Docker so that I can see only the Kafka instance without any uh, confusion. So here I opened the command prompt in this location, and I'm going to execute this Docker up. So Docker compose up -d. So let's run this and see. Um, so it's see you can see it's creating the Confluent CP Kafka. Then it created the UI. Let's open your. It's still doing that. So yeah, it took a while, but it created the UI first, and then still the Kafka image pulling is in progress. Yes. Yeah, it's completed. You can see this is Kafka image and this is the Kafka UI image. And if you open the container, you can see this is the Kafka UI and this is the Kafka. So if you click on this one, so you can see uh, all the brokers. So this is your Kafka instance in your local. And there are no topics yet. You can create a topic here. Test my UI topic. Uh, Partitions are mandatory. You can give two or one, anything. So in the production, you can give 12, 8, something like that. And you can create the topic. So here again, you can, this is really powerful and I like the tool. So it has consumers. You can create the consumers here. We will see that later. And these are the settings of your topic. And you can see the uh, you can analyze your statistics. So simply you can add filters here, and you can create messages here. Um, so there are no messages. You can add the filters. So based on the filter, the messages will be uh, processed. So we we have created the Kafka in the Docker, and we created the Kafka UI so that you can operate the Kafka UI. And these are few commands. We don't use them um, like more frequently because in my applications I used Kafka for real-time events. So there is no way I create. Till now, I didn't use the command to create the topic uh, and to publish the messages and to consume the messages. But you can. These are useful. You can just explore them um, so that you'll understand Kafka in more detail. This command is for creating a Kafka topic. So I'm going to copy this command. So you can see Docker exec hyphen it Kafka Kafka topics Kafka topics hyphen create hyphen topic and topic name. This topic is a topic name and bootstrap server, and the server is localhost 1992. So here, if you see, Kafka is deployed in 1992, uh, but you cannot access them. But this UI is the UI image is deployed here, which is accessing this Kafka. So if you want to create a topic in the Kafka, you have to use 9092. Just copy this, put it in the command prompt, enter. So it's going to created test topic. Go to your UI, refresh the topics. Yeah, it took a while because all these are heavy. Like there is a lot of background processing happens when you're executing this command. So you can expect a delay, especially in your local. This is my local. So that's why when you are processing Kafka, you will use asynchronous way and you will delay the activities. So here, this is the topic which I created by using the command. So there are no messages yet. I'm going to publish a message and you are going to see that here. Second command is going to publish a message to your Kafka. So again, Docker IT Kafka Kafka console producer. So here I used Kafka topics, but here it's a console producer. By using the console, I'm producing a message to the Kafka. And what is the topic name? Test topic, and where you deployed it, this one. So this command is going to produce a message by using a console into the location. Just copy this, and now I pasted the consumer, the producer Kafka message. Just enter it. So this is my console generated Kafka message. You can put it. If you click on Control C, it's going to uh, exit the command. So this is the message I'm looking forward to see. So you can refresh it. You can see this is my console generated Kafka message. And if you see the overview, partition 1, replication factor, so segment count, message count is 1. So you can submit the messages like this, and the next command is going to consume the messages. Um, so this third command is going to consume the message by using the console only. So it's similar, Docker exec Kafka console consumer. So this is console producer and this is console consumer. And what is the topic name? And from the beginning, so you can have multiple messages, but this is going to consume the messages from the beginning. Uh, so whether they read or not, copy this, put it here and execute. So it's going to consume the message and it's consumed. This is my console generated Kafka message and it's waiting for the commands. Yeah, processed a total of 1 messages. Processed total of 1 messages. If you have multiple messages, the consumer will uh, uh, process all the messages. So the conclusion, this is really interesting and my favorite topic in the Docker, Kafka. So we are covered a lot of interesting things in this video. So the introduction to Kafka, we completed introduction, what is Kafka and advantages of Kafka, how Kafka is being used and what are the competitors for Kafka, and then how to create Kafka in Docker. So there is a Zookeeper version and KRaft, Kafka Raft Craft version. So I go through both the uh, versions in the Docker Compose, but I choose KRaft, which is the latest Kafka variation, and I created um the Kafka image and container in the Docker by using the Docker Compose, and then I created Kafka UI so that I can manage the Kafka entity in the browser. Then we have gone through a few important commands like how to create a topic by using command and how to um, produce a message to the Kafka and how to consume a message from Kafka. So yeah, these are the things we covered. I hope you like the video. Thank you so much for watching my video and uh, uh, please provide your feedback in the comment section and also let me know if you need any specific topics on Kafka or Docker or any cloud computing. So I'll try to make some time and make the video. Thank you so much. Happy coding.